have a GEMINI project meeting in Krakow for 2 days. It was organized jointly by Sano Center for Computational Medicine and Academic Computer Center Cyfronet in the premises of the Academic Center for Materials and Nanotechnology. It's a very important project for both, for Sano Center and for Cyfronet.
Our purpose, the goal of the project, is to deliver digital twins in healthcare that can be used as decision support in treatment of strokes. These can be hemorrhagic strokes or these can be ischemic strokes. And the project is now running for 18 months and we now really start to see to come things together. We have 19 laboratories, companies, medical hospitals working together. We see very, very exciting results and the project will continue for 2.5 more years to do technical developments. And this is extremely exciting, we are preparing for a prospective trial to actually put this into practice.
The important thing that we do is we're collecting data together with the clinicians and we organize the data. And one of the key challenges that we have is these data sets are evolving over time. And so we have to make sure how to improve models also over time. And we have very different input data. We have imaging data, we have categorical data, and then we have input data also from the other work packages. And so it's a lot of information that we have to federate all into the right models. And really the question in the end is what is the right model and how does that evolve? And to make that in the end subject specific, population specific, I mean, that's a challenge that we have in this work package.
We are mostly in charge of providing the computational backend, which is required for large-scale execution, development and testing of those models. This is primarily taking place at Cyfronet, which is our advanced partner here at Sano. And as far as the role of Sano is concerned, it deals with facilitating the activities related to, as I've said, VVUQ, which is essentially asking ourselves, are we asking the right questions? Do the tools that we develop provide appropriate answers to those questions? To what extent those tools can be used in practice? What factors they're sensitive to? What is the inherent uncertainty in the predictions provided by these computational models? I'm obviously referring to the stroke and thrombectomy models that are being developed in the scope of GEMINI.
I think it's very interesting, the developments. We are now building up all the tools, all the modeling tools that is really relevant for the stroke descriptions. Moreover, I also see the developments in the hospitals. Our stroke treatment is really changing. The information that is lacking, and we can really provide that information and give much more knowledge about stroke, about the treatments that we in clinical practice using the digital tools. So that's a very exciting development, I would say.
But for me, one of the unique aspects of GEMINI is the multi-organ aspect. So we've managed to work different research teams that were focused only on one organ to work together and to really work together on the heart-brain axis in terms of the hemodynamic models. And then another important aspect has been the verification and validation, how to collectively gather data and a lot of challenges ahead.
Well, I'm very impressed by the simulations made by the team from Milano. They look very impressive and I think they will be very beneficial for physicians in the future to decide which treatment to use in a specific patient.
So I'm working on medical image processing, particularly extracting medical images from the Hospital of Geneva, especially for the research on aneurysm segmentation and simulation of deployment of medical devices. So this way we support other research groups to work on hemorrhagic stroke.
For us, it's a little bit different because we are software engineers. We are dealing with the software basically. So for us, the basic challenge in the scope of the project is to simplify this project for the people who our main objective is not connected with IT. So we are trying to provide the solutions which can make their life much easier.
So our main responsibility would be to help people developing things. So usually their stuff runs on laptops, but they need to port it on a supercomputer, and supercomputer works quite differently than what they are used to. So we try to facilitate the process, so it is easier for them to run on supercomputers, and it is easier for us to understand what they're doing there.
Well, what I think, and also what I hope, is that it can really help guide treatment decisions. And what I've tried to show is that new techniques are adopted quite fast in routine care, as long as they impact management, impact decisions. So as long as tools are developed that fulfill one of those needs, then it can be very quick. And I think it is very promising, right? I mean, developing tools to better predict which patient to treat, or maybe which technique to use in a particular patient, which endovascular technique to use. I mean, those tools can be incredibly handy